Hello everyone, I am Teacher Gu. Today's topic is the product training of the AISTEAM series. The training mainly consists of 5 parts. This part mainly introduces line tracking. There are countless colors in nature. However, in computers, colors are composed of 3 primary colors: red, green, and blue. When the world loses its colors, the degree of lightness and darkness represents grayscale. This is our integrated 5 grayscale sensor. It has 5 channels. The grayscale value can be detected through real-time data. It is installed in the A5 port during installation. Click the black arrow to select the grayscale sensor. Then, how to do black and white calibration. First is the preparation. We need to download the black and white calibration module. Then install the display screen, and the screen will show AISTEAM. Then, the calibration is achieved through 4 steps. Step 1. Run the program, and a black check will appear. Step 2. Align with black line, press button. Step 3. A white check will appear. Step 4. Align with white line, press button. Then check success appears, indicating completion. When aligning with the black line, the value usually shows 4000. When aligning with the white line, the value is generally no more than 100. Then I'll explain the principle of line tracking. Generally speaking, the more grayscale sensors are used, the more accurate the line tracking, and the smaller the jitter. The principle of line tracking is to walk along the line. If it deviates to the left, turn right. If it deviates to the right, turn left. In short, walk along the line. In the competition, we often need the robot to move along a specified route. At this time, we need to use grayscale to patrol the line. Then it is the normal intersection patrol. First, set the initialization to black line. Then set the power. M1 is 0-1, M2 is 1. Because the 2 motors of the car are opposite when installed, it needs to be set to a negative number here. We can see that the picture shows a left intersection, because there is a black line on the left. So it needs to be set as a left intersection in the program. The time for crossing the intersection is set to 0.5 seconds, which is to allow the car to straighten its body. If the car turns immediately when it encounters the black line, it will deviate from the route, and the turn will fail. At the same time, we must ensure that the black line is in the middle of the car. When the car reaches the second intersection, it can be set whether it is a left intersection or a right intersection. Then it is the mechanism intersection patrol. This line tracking is similar to the previous one, but we need to set the power to a negative number. The other principles are the same. During use, taking normal intersection patrol as an example, we can find intersections through line tracking. Intersection types include left intersection, T-intersection, crossroad, and right intersection. In programming, we can set the speed, select the type of intersection, and the time to cross the intersection. The same is true for mechanism intersection patrol. You can set the speed, the intersection, and the time. Next, turn left at the normal intersection. The robot rotates leftward in place with its center until the grayscale sensor detects a black line and the robot stops. Then, the same goes for turn left at the mechanism intersection. Next, turn right at the normal intersection. The robot rotates rightward in place with its center until the grayscale sensor detects a black line and the robot stops. Then, the same goes for turn right at the mechanism intersection. Next is normal intersection line finding. The robot moves at a certain speed until the gray value of 3 is greater than 2000, indicating that the black line is found and the robot stops moving. The same is true for mechanism intersection line finding. This is the introduction of the line tracking. Thank you for watching. See you next time.